inequality. Triangle inequality. Now what is the triangle inequality? Let us consider the two complex numbers Z1 and Z2. For these two complex numbers Z1 and Z2, first we can find the sum of these two complex numbers, then you can take a modulus. This is always less than or equal to modulus Z1 plus modulus Z2. This is always less than or equal to modulus Z1 plus modulus Z2. That is, this is called triangle inequality. This is called triangle. Now let us prove this one. How do you prove? We can go for proof. Now consider this one, Z1 plus Z2 modulus whole square. Z1 plus Z2 is modulus of Z1 plus Z2 whole square. Now we know very well modulus Z square is equal to nothing but Z into Z bar. Modulus Z square is equal to Z into Z bar. Therefore here you consider this entire number as a complex number. For that you are having what a modulus Z square means that can be Z into Z bar. In place of Z what we have? Z1 plus Z2. Therefore you can write Z1 plus Z2 into Z1 plus Z2 whole bar. Based on this property we have written. Okay? Yes. Now this we can write as a consider. Yes. Now after that see, we know very well this we can write as Z1 plus Z2. Now this Z1 plus Z2 whole bar, using the conjugate of a complex number properties, we can write Z1 bar plus Z2 bar. You know very well Z1 plus Z2 whole bar equal to Z1 bar plus Z2 bar. Now just to remove this bracket, ordinary multiplication, just you can write take Z1 multiply with Z1 bar. You can write Z1 into Z1 bar. Z1 into Z1 bar. Then you can take this one plus Z1 into Z2 bar. Then you come for this one plus Z1 bar into Z2. Z1 bar into Z2. Then plus can write Z2 into Z2 bar. Z2 into Z2 bar I have written. Okay, now after this, see here, we know very well this Z into Z bar equal to modulus Z square. If it is Z1 into Z1 bar, it will be modulus of Z1 square. Therefore, for this one, we can write as modulus Z1 square. Modulus Z1 square. Okay. Now here plus, we can write Z1 into Z2 bar as such. Then plus. Here you can write Z1 bar. This Z2 can be written as Z2 double bar. Z2 double bar. Because we know very well Z double bar is equal to Z. Z double bar equal to Z. Therefore, Z2 double bar is equal to Z2. Therefore, I replace this Z2 as what is Z2 double bar. Then after that we can go for this one again. This is based on the same property, Z into Z bar. Z2 into Z2 bar equal to modulus of Z2 square. Therefore, this can be written as modulus of Z2 square. Modulus of Z2 square. Okay. Yes. Now, see here, you can write this as modulus Z1 square plus Z1 into Z2 bar plus. Now here this can be written as Z1 and Z2 bar. Then you can write as a whole bar. That is Z1 bar into Z2 bar can be written as Z1 into Z2 bar whole bar. Based on this property, Z1 into Z2 whole bar equal to Z1 bar into Z2 bar. Therefore here, see, this is Z1 bar you can get. This is Z2 bar, again another bar you get is Z2 double bar. Now plus this can be written as modulus Z2 whole square. Okay. Yes. Now till this we have written. The next one is See here, this is modulus z1 square plus. Now this is nothing but, listen here, this you consider one complex number. This is its conjugate. This is z1 into z2 bar, one complex number. This is z1 into z2 bar whole bar. This is nothing but z plus z bar. Already we have seen one result. Real part of z is equal to z plus z bar by 2. This result already we have seen. That is, real part of z is equal to z plus z bar by 2. Now you bring this to this side, then you will be getting 2 times real part of z is equal to z plus z bar. 2 times real part of z is equal to z plus z bar. Therefore, if you consider this as z, this is z1 into z2 bar as z. This is z bar. Consider this as z, this is z bar. What is z plus z bar? 2 times real part of z. This is 2 times, what is real part? This one, real part of z, which is z. z1 into z2 bar. z1 into z2 bar. Now this thing I have written as this one. Z plus z bar equal to 2 times real part of z based on this property. Okay, then after that we can write this as plus modulus z2 whole square. Modulus. See, we have one result, that is a real part. This is one of the property. I will prove it later. Real part of z less than or equal to modulus z. Similarly, imaginary part of z is less than or equal to modulus z. Okay, now here we have this modulus z1 square plus here 2 is there. You consider this alone. Real part of z. Real part of z less than or equal to modulus z. Therefore here this real part of z less than or equal to, here we cannot write less than or equal to, where you have equal to sign, there you can change it as less than or equal to. This is less than or equal to. Here we cannot write the symbol less than or equal to. Therefore, where you have equal to sign, there only you can replace as less than or equal to. 2 times, what you can say, modulus z. What is modulus? Modulus of z1 into z2 bar. z1 into z2 bar plus modulus z2 square. Modulus z2 square. Okay, based on that result, right hand side is greater than the left hand side. Right hand side is greater than the left hand side. But here I am going to write the next step, which is equal to the right hand side. There we can here put what equal sign. Finally, we can write again less than or equal to. Now, here this we can write modulus z1 square plus 2 times. Now we have another property, modulus of z1 into z2, which is equal to modulus z1 into modulus z2. Therefore, modulus of this product of two complex numbers can be written as the product of their moduli. That is modulus z1 into modulus z2 bar plus modulus z2 the whole square. Now, which is equal to modulus z1 square plus 2 times modulus z1 into modulus z2, because we know very well modulus z is equal to modulus z bar. Therefore, modulus z2 will be modulus z2 bar. Therefore, this modulus z2 bar can be written as modulus z2 plus you can write a modulus of z2 the whole square. Now, this is of the identity a square plus 2ab plus b square. In the place of a, what you have? Modulus z1. Modulus z1. Then in the place of b, what you have? Modulus z2. Now this is of the form a square plus 2ab plus b square means a plus b the whole square. This is a plus b the whole square. Now these two are equal, but while comparing with the left hand side, this is greater. Therefore, finally we can write a modulus of z1 plus z2 whole square less than or equal to. Because while comparing right hand side, this left hand side is lesser. Therefore, you are writing modulus of z1 plus z2 whole square less than or equal to modulus z1 plus modulus z2 the whole square. Now we need only this modulus of z1 plus z2. Therefore, on both sides you can take positive square root. Taking positive square root. Taking square root. What can you get? Modulus z1 plus z2 less than or equal to modulus z1 plus modulus z2. Now this is called this triangle inequality. Now let us see its geometrical meaning. Geometrical meaning of this triangle inequality. The triangle inequality is modulus of z1 plus z2 is less than or equal to modulus z1 plus modulus z2. This is triangle inequality for these two numbers z1 and z2. Now listen here. You can take a complex number. This is z1. This is origin. Now you can take this is a complex number is z2. This is from the origin. Okay. Now if you consider this distance of this complex number z1 from the origin is nothing but its modulus. Therefore this will be modulus z1. Similarly this will be modulus z2. This is modulus z2. Now by taking this OZ1 and OZ2 as the two adjacent sides of a parallelogram, we can complete a parallelogram. Already we have seen in the addition of two complex numbers. Now, this is nothing but sum of two complex numbers z1 plus z2. Already we have seen. Now here, if you consider this distance of this z1 plus z2 from the origin is nothing but its modulus. Modulus of z1 plus z2. This modulus of this z1 plus z2 is nothing but distance of this point from the origin. This modulus of z1 plus z2. Since it is a parallelogram, these opposites are equal in magnitude. Therefore, this OZ2 is nothing but z1, distance between z1 and z1 plus z2. Therefore, this also will be modulus z2. This also will be modulus z2. Therefore, if you go for triangle of addition, this is z1, this is z2 means this is z1 plus z2. A vector, B vector. This is nothing but A vector plus B vector like that you can take. Therefore, this will be modulus of z1 plus z2 we can consider. Okay. Likewise, see here what it means. Why we are calling this as triangle inequality? See, if you want to draw a triangle, how many measurements you need, how many sides you need? You need what? 3 sides. Generally, you can draw the triangle. For example, if you have a triangle sides like this, 5, 3, 4. Can you draw a triangle with these measurements means? Yes, you can draw. Now, suppose you take this one, 2, 3 and 9. With the help of these 3 measurements, can you draw a triangle? Means you try yourself, but you cannot draw a triangle with the help of these 3 values. Therefore, any 3 values are given, you cannot construct a triangle. For that, there is a condition. That is, it should satisfy this condition, that is triangle inequality. What it means you take in a triangle, suppose you have a triangle, this is side 1. That is, you can take A, this is B, this is C. We have 3 sides. With the help of these sides, we have to check whether these 3 sides satisfies triangle inequality. What it means? See here, you can take one side, this side. This must always be less than or equal to sum of the other 2 sides. This should be less than or equal to C plus B. You can take side B. This must be less than or equal to sum of the other 2 sides what? A plus C. Or you can take C. This should be less than or equal to sum of the other 2 sides. So what means A plus B. For example, here you can take one side. 5 is less than or equal to sum of 3 plus 4. Or you can take 3 less than or equal to sum of 3 plus 5. Sorry, 4 plus 5. Or you can take 4. This is less than or equal to sum of 5 and 3. See, if you find what any one side, that must be always less than or equal to sum of the other 2 sides. See here you can take this one. See here you can take a 9 less than 2 plus 3. These things are right. Can you say this is right? Therefore, with the help of these three measurements, you cannot construct a triangle. Therefore, whenever you want to construct a triangle, we must have this condition, that is a triangle inequality. If you take any side of a triangle, that should be always less than the sum of the other two sides. If it is equal, means we can say the points are collinear. Okay, in such case we can say there is a triangle with area 0. But here therefore you are saying less than or equal to. So therefore if a side is always less than or equal to sum of the other two sides, definitely we can construct a triangle. Based on this condition, if you consider this triangle, any one of these two, we have two triangles, you can consider any one of these two triangles. See here in this triangle, modulus Z1 is one side, modulus Z2 is another side, this modulus of Z1 plus Z2 is another side. Therefore, if you consider this one side, that is modulus Z1 plus Z2 is always less than or equal to sum of the other two sides, Therefore, this can be considered as the what? Triangle inequality. Okay, now based on this, we can write some more results. Therefore, see here modulus of Z1 minus Z2. What is the value of modulus of Z1 minus Z2? Let us see. If we consider Z1 as x1 plus iy1, Z2 as x2 plus iy2. See, modulus of Z1 minus Z2 means first we can find Z1 minus Z2. What is Z1 minus Z2? x1 minus x2 plus I into y1 minus y2. Then you have to take its modulus. Modulus of Z1 minus Z2 is equal to Z1 minus Z2 means you have to subtract real part from the real part, imaginary part from the imaginary part. This I is common. Now here this is in the standard form. What is modulus of a complex number? Modulus of this complex number is nothing but root of real part square plus imaginary part square. Therefore, root of x1 minus x2 is the real part whole square plus imaginary part is y1 minus y2 the whole square. y1 minus y2 the whole square we can write. Therefore, here modulus of Z1 minus Z2 is equal to root of x1 minus x2 whole square plus yn minus y2 whole square. This is nothing but the distance formula, distance between the 2 points. Now, what are the 2 points considered? Z1 and Z2. This is Z1, this is Z2. Now, the distance between these two is, this is nothing but what? Modulus of Z1 minus Z2. This is nothing but modulus of Z1 minus Z2. Therefore, whenever you consider modulus of difference of two complex numbers is nothing but distance between these two complex numbers. But sum of the complex numbers is nothing but one of the vertex of the diagonal which is drawn from the origin. Therefore, these two things you must always remember. Okay, now therefore modulus of Z1 minus Z2 is equal to nothing but distance between the two complex numbers Z1 and Z2. Okay, now let us see the next one. Some more results based on the triangle inequality. See, for the two complex numbers we have the triangle inequality. Modulus Z1 plus Z2 is always less than or equal to modulus Z1 plus modulus Z2. Now, if you replace Z2 as minus Z2, we are replacing Z2 as minus Z2 means we can write modulus Z1. Z2 are replacing minus Z2. You can get minus Z2 less than or equal to modulus Z1 plus modulus of minus Z2. Modulus of minus Z2. Now we know very well modulus of Z1 minus Z2 less than or equal to modulus Z1. This is nothing but modulus Z2. Because already I told modulus of Z is equal to modulus of minus Z is equal to modulus of Z bar. All these results are equal. Therefore, whenever you have minus of Z2, its modulus also will be equal to it's Z2. Therefore, modulus of Z1 minus Z2 is also less than or equal to modulus of Z1 plus modulus of Z2. For example, if you consider this one, origin, this is Z1, this is Z2. Now, this is nothing but another term you can get. This is modulus of Z1 minus Z2. Modulus of Z1 minus Z2. Therefore, you can take this as modulus Z1, this as modulus Z2. Here also you can say, in this triangle, this is one of the sides. Therefore, this side will always be less than or equal to sum of these two sides is in here. Okay. See here, if you are taking this one, modulus of Z1 minus Z2 less than or equal to modulus of Z1 plus modulus of Z2. If you add these two things, definitely, if you add these two sides, definitely the sum of these two sides is greater than this third side. This is sum of two sides is always greater than the another side. Suppose instead of adding, if you subtract, that is a modulus Z1 minus modulus Z2. While subtracting, we don't know. This modulus means always distance. Okay. Now we don't know which is smaller. Z1 is smaller or Z2 is smaller. We don't know. Therefore, while considering the distance, always you have to take the modulus. That is the modulus of Z1 minus Z2. Sum of two sides always greater than the third side. But difference of two sides will always be less than or equal to the third side. Therefore, you can say less than or equal to modulus Z1 minus modulus Z2. Modulus of Z1 minus Z2 less than or equal to modulus Z1 minus modulus Z2. Similarly, you can write a modulus of modulus Z1 minus modulus Z2 less than or equal to modulus of Z1 plus Z2 from this result. Okay, while adding, definitely the sum of these two sides will be greater than the third side. If you find the difference, definitely that difference will be less than or equal to this third side. Therefore, by combining these two results, so this result and this result, by combining these two results, this Z1 modulus of Z1 plus Z2 have been middle. Therefore, we can say modulus of modulus Z1 minus modulus Z2 less than or equal to modulus Z1 plus modulus Z2 less than or equal to modulus Z1 plus modulus Z2. By combining these two results, I have written like this. Similarly, we can write another result. Similarly, based on these two, see this and this, based on these two things, we can write here modulus of modulus Z1 minus modulus Z2 less than or equal to modulus of Z1 minus Z2 less than or equal to modulus Z1 plus modulus Z2. Therefore, these two results are very important whenever you have to find the boundary values that you will see later in the problems. Okay. Therefore, these two things are very, very important. You try to keep in mind. Okay. Now let us see the modulus of a complex number and its properties. Okay. In the next class, we will see the exercise problems. Till then, you try to revise these things. Thank you, children.